Okay. Just like to introduce Andy Weir, VK2, sorry, AAK, who was and published in Amateur Radio magazine an article. If you assume everybody's read it, of course, right? And that got me interested because I know that Bill and Bob and a few others are into satellites. So I decided to give Andy a ring. Being the curious bugger I am, I just got onto the ACMA website and then got onto the white pages and found somebody with the address that lined up, and bingo, it worked. So anyway, Andy's also got a couple of YouTube videos published. If you search for Andy's workshop on YouTube, you'll find there's a few videos there on repairs and work he's done. And he's also, if you got QRZ up, you'll see his page on QRZ, which shows a nice picture of his shack. So with that, I'd like to hand it over to Andy and thank him very much for coming tonight. And unlike the first invite, it's not actually in regard to the aerial side of things, it's in regard to the use of and satellite comms and associated subjects. So I'll let Andy have the floor. Thank you, my friend.
Thank you. Thank you, Stuart. Can everybody hear me okay? Just nod.
Yep.
Okay, good, excellent. I do have a couple of videos and hopefully the audio will be okay. I'm not quite sure about the levels. Thank you for inviting me to speak. It's quite an interesting story about how it came about. Stuart has explained that article in Amateur Radio magazine actually grew out of a Facebook post. I made a comment on a Facebook post in one of the groups, and somebody sort of took me to task about the antenna, and so I answered it, and it turned out they didn't quite believe that it was me and my antenna, and they actually had that picture that you've seen in the AR magazine as the banner picture for their group. And I said, yeah, well, yeah, not only is it me, you've actually got my picture as the banner on your group. And anyway, Roger Harrison posted on the group and said, oh, can you tell me a bit more about the antenna? So I did, and he emailed me back and said, oh, that's quite interesting. Can you add a few more words and a few pictures, and we'll publish it as an article in Amateur Radio magazine. So that's how it all sort of happened. It actually just grew out of a one sentence comment in a Facebook group. So there we are. As Stuart said, I'll talk a bit about satellites. I will actually talk about that antenna. It's sitting behind me here, and I will talk briefly about that. I apologize if this isn't as slick as you would normally wish. I'm not a Zoom expert. I do chat with my brothers every week. I have a brother in the UK and a brother in the US, but I'm by no means an expert. So if things go wrong,
no apology needed, mate. All good.
Yeah, if anything goes wrong, just let me know. And if you can't hear me, or if the audio's wrong, just sort of stop it, and we'll fix things. So we'll talk a bit about orbiting satellites. I was perhaps I wasn't quite so fortunate. I was fortunate to be born in the early 1950s, and my father took an interest in things sort of scientific. And one of my enduring memories is my father taking me out into the back garden of our house and watching a tiny little speck of light moving across the sky, which was Sputnik 1, the very first artificial satellite. And I've had an enduring interest in that sort of thing ever since. It quite interesting to think that it was only 4 years after Sputnik 1 was launched that the first amateur satellite was launched. 1957 was Sputnik 1, and Oscar 1 which was the first amateur satellite, was launched in 1961. OSCAR, OSCAR, is an acronym. It stands for Orbiting Satellite Carrying Amateur Radio. And OSCAR 1 was not terribly sophisticated. It was fairly large. It contained a very simple CW transmitter, which transmitted high in Morse code, and the speed of the Morse was proportional to the temperature. So that was the very sophisticated telemetry. The high got faster and faster the hotter the thing got. So it had no solar panels or anything like that. It was simply a battery and a little transmitter, and it went round for a few weeks, much the same as Sputnik 1, transmitting high, and then eventually burned up in the atmosphere. But it was a start, and things progressed quite rapidly and quite well from there. And we went from simple battery-powered satellites to satellites with solar panels on, which would last a little bit longer. And the payloads in the satellites got a lot more sophisticated. Instead of just a simple beacon that transmitted high, we had cameras, which you could get almost like a sort of slow scan picture, but that sort of quite low resolution, as well as beacons, repeaters, essentially repeaters. They actually call them transponders, but we'll go into that a little bit later on. We've had packet radio, store and forward repeaters, and probably the peak was the phase 3 satellites in the 80s, which carried some quite nice linear transponders, which essentially took a chunk of VHF spectrum and retransmitted it as UHF spectrum, and it was a sort of linear relationship. It wasn't just like a single channel. It was a whole chunk of spectrum which was transponded into another chunk of spectrum, and so it could accommodate quite a lot of people and quite a lot of continuous sort of simultaneous QSOs. I will share my screen now and show you some pictures. Let's have a look and see if we can find that. That should be working. Can you all see that shared screen?
Yes, mate, it's working.
Okay.
Yes.
Excellent. Okay.
Just yell if you have any trouble getting out of it.
Yeah, just got to find my mouse cursor.
By the way, there's nothing wrong with being born in the early to mid 50s.
Okay, can you see that?
Yes, thank you.
Okay. The first, that image there shows a simplified version of the types of orbits. The satellites we're going to talk about predominantly tonight are the first on the top left there, the low Earth orbit satellites, this type. Geosynchronous, you'll be familiar with geosynchronous satellites. Most of the TV satellites, that sort of thing, fall into the geosynchronous orbit. And the other type down here, these highly elliptical orbits, or what's called a Molniya orbit, those were the phase 3 amateur satellites. They were very, very clever. People quite often don't quite grasp how an orbit works. They basically think you fire a rocket straight up and it sort of goes into orbit. To explain orbit in a simple way, if you can imagine an object on the end of a piece of string, and you whiz it round and round your head, the string holds it from flying away, and the fact that you're whizzing it round and round, centrifugal or centripetal force tries to push it out. Well, it's exactly the same thing with a satellite. You send an object up, and you send it spinning around the Earth, and the speed at which it's spinning balances against gravity. So you've got centripetal force trying to push it away, and you've got gravity trying to hold it back. And because there's no friction, really, you're outside the atmosphere, it just goes round and round. If you try to go faster, it gets further away. If you get out to a particular distance from the Earth, the time it takes to go around the Earth is exactly the same as the time it takes for the Earth to rotate. So the satellite appears to be above the same point all the time. So and that's what a geosynchronous satellite is. It's actually orbiting, but it's orbiting at the same speed that the Earth is rotating. So it appears to actually stay there. Of course, it has to be over the equator, because the Earth revolves around the equator opposite the axes. If it wasn't, it would appear to be sort of over the same place, but it would appear to go up and down if it was above or below the equator. As the Earth rotated, the satellite would be at a different plane to the equator. Anyway,
just one quick question there, Andy. So geosynchronous and geostationary are basically synonyms.
Same thing.
Yep.
Yeah, geostationary and geosynchronous are just exactly the same thing, just a different word for the same thing. Yeah. The highly elliptical orbit, this one down here, probably one of the most well-known amateur satellites was Oscar 10, which was used in the 1980s. And that type of orbit, it would seem to hang in the sky a long time. It went out, it would come back, whiz around the Earth and go way out. And so it would appear to hang in the sky for hours and hours at an end. And I was able to work, I can probably show you some pictures. That's just another picture of the elliptical orbit. That was the setup I used. That was my shed up in Kempsey, and you can probably see, I hope you can see, the tower on the left there, and there's a couple of Yagis on the top of the tower. They're just crossed Yagis, and it had a relay switching arrangement in the thing with phasing lines, and I could change it between right and left hand circular polarization. I hope that fan isn't whining too much. I can hear it on my computer. And I could change the things in elevation as well as azimuth. And I was able to work right up to Northern Europe. And the satellite for me would be 1 degree above the horizon, and the satellite for them would be 1 degree above the horizon. And we were really sort of stretching the limit. But that's when it was out at its furthest point. And it's probably, there's a QSL card from, who's he? G6DTW, I think. These are all on Oscar 10. I'll leave that up there for a moment. No, I'll actually.
You're the old tape measure.
I'll just go back to stop sharing. Am I back?
You're back.
Jolly good. Okay. So the amateur satellite program sort of progressed quite well. It wasn't entirely all plain sailing, however. There were some launch failures, and this was the biggest problem, of course, getting with amateur satellites. The early ones literally were built in people's garages, and building the satellite was the easy part of the project. Getting a launch was proved quite difficult. So they would, use influence, people they know, and however to get a launch. And sometimes they were launch failures. One of the phase 3 satellites, like the Oscar 10 type satellite, I think it was an Ariane rocket, and it blew up on the launch pad. Probably one of the notable instances of things not going quite to plan was a satellite built by amateurs in the University of Surrey in the UK. It was called, it ended up when it was in space as Oscar 9. As you're probably aware, most satellites have some sort of telemetry, so they can sort of see what condition the batteries are in and that sort of thing. And it also has a command system whereby they can turn certain things on and off. They can turn transponders on and off. And there was a bit of an error in that they turned both the 145 megahertz and the 435 megahertz beacons on at the same time. Now these antennas are this far apart, so they've got two antennas both transmitting that far apart, which completely upset and overpowered the command receiver. So they essentially lost control of it. They couldn't talk to it because it was talking to itself. It was two antennas that far apart. So they called upon some amateurs at Stanford University in California, and they used a 150-foot dish. They put a 2-meter transmitter up at the focus of this dish. The effective isotropic radiated power was 15 million watts, 15 megawatts. And the guys in California said, well, we'll either command it or we'll melt it. And it actually worked. They managed to get through to the satellite. They commanded the beacons off. They were able to regain control. And this was 6 months after they lost control, but the satellite went on for another 7 years and worked very well. So, and it's quite interesting that in the amateur satellite program, amateur satellites have generally been very reliable, far in excess of their design lives. And people who were working in the industry, they sort of poo-pooed amateurs by building satellites in garages and said, oh, it'll never work, it'll never happen. And these things outlived commercial satellites by years and years and years. So things were done very well. I mean, it wasn't a lack of skill. Things were done incredibly well. I've lost my mouse cursor. There we go. I will just bring up that screen again. This brings, you can all see that picture? Yep.
Yep.
That brings us up to the current era, really, of satellites. That's what's called a CubeSat. And they are a 10 centimeter by 10 centimeter by 10 centimeter cube, hence CubeSat. They conform to that size, and they fit into a launch vehicle in a predefined space. It's not ad hoc. These things are. It's a lot easier. They're small. You know that if you build a CubeSat to the design, it's going to fit in the vehicle that they're going to launch it in. And consequently, the cost of launches has come down quite considerably. A lot of these things, you'd be surprised at the lack of sophistication in quite a lot of launches. Quite a few amateur satellites were launched by the space shuttle, and they almost literally throw them out the door. They basically just chuck them out in the right direction.
Just out of curiosity, what would the nominal cost of a CubeSat launch be? What's it cost to put one?
I think it's down now into like 100,000 or under, I think, whereas previously I mean, back in the 60s and 70s, it might have been $100,000, which would probably equate to a couple of million these days. It was and so it was all done on favors. These days it's a lot more formalized, but it's a lot more cost effective, and societies and universities and that sort of thing often provide the funding. And I'd have to look it up, but CubeSat launches are now sort of well within the reach of societies and particularly universities. You can probably see sticking out the side of that satellite, the yellow object there. I'll give you a clue as to what it is. I'll just stop the sharing for a minute. It's actually the antenna, and the antenna is made out of one of these. This is a tape measure, and the reason for that is that these things, of course, can be wound up, and when the thing is in orbit, they can just release it. It springs out to the right length. There's no gravity, so it's not going to break, so you can have quite a nice long one. And it doesn't require a motor to drive the antenna out. They just sort of undo a catch and the thing springs out. Very common thing. They don't usually mark them in inches and centimeters though, but yeah, I'll just bring that back. I've lost my mouse cursor. There we go. That's another view of a CubeSat. You can see inside the thing. That's the battery pack in the middle. That is actually Oscar 91. That is AO 91 itself. 10 centimeters by 10 centimeters by 10 centimeters. Some solar panels on the outside. It has some batteries. It's pretty much identical to Oscar 92. They're very similar satellites. Some of the latest ones are a half-size CubeSat, 5 by 5 by 5 centimeters. Now, 5 by 5 by 5 centimeters. I mean, it's smaller than a tennis ball.
Just out of curiosity, is that a mag loop on the side of it, magnetic loop type antenna?
I don't know if it's a magnetic loop. I'm not quite sure exactly what that is. I thought it had the tape measure type antennas.
Because it's just looking there, it looked like there was a feeder loop down low at the bottom.
It does look a bit like it. I'm just looking at it now. Not really got the resolution. I'm really not sure. In fact, I'm not even totally sure that it's an antenna. It sort of looks that way, but I'd have to look up the specs of the satellite to find out. Yeah, I thought it only had sort of basically a rod antenna, but I can check that anyway. Yeah, 5 by 5 by 5 centimeters. Some of the latest ones, which are, I mean, it's ludicrously small. It's tiny, but quite sophisticated, quite clever. Now, to let me just have a look here. What else I've got here? Okay, all right. Working through these satellites. Satellites like Oscar 91 and Oscar 92, or AO 91 and AO 92, are generally called the easy satellites. They're FM. It's a single channel, almost a repeater. If you can imagine, it's a flying repeater, almost. And the equipment you need to work through them can vary from very, very simple to as sophisticated as you really want it to. I've got some videos, but I won't play that just yet. I'll just go back to those pictures and move my mouse over here. What do you need? Okay, that's I've got some videos which I'll show you in a minute. That's the radio I used. It is just a straightforward dual band handheld. That one happens to be a DMR handheld, but it's analog and digital. I only used it for the analog part of it, and it runs about 7 or 8 watts on 70 centimeters, a little bit more on VHF. But nothing's special or sophisticated or different about it, just a straightforward handheld radio. I will Also demonstrate one of the base station radios here, just running through a discone antenna. I'll just stop that share and go back to me. So things you need a radio. It can vary from something like that dual band handheld. You can, if you're good at juggling, use two separate radios, a 70 centimeter monoband radio and a 2 meter monoband radio. Up in sophistication, there are radios which are specifically made for running satellite. On the desk in front of me, you can't see it because it's around the back of the computer, is a Kenwood TS2000, and it has a satellite mode. Probably one of the earlier examples of that sort of radio was the Yaesu FT726, and I did have one of those, my pride and joy, back in the 80s. I actually worked for Dick Smith, so I got it quite cheaply because they were the agents in those days. But it had two receivers. It would work in full duplex. It could transmit and receive simultaneously on different bands, and it had tracking VFOs, and it was great for satellites like Oscar 10, which had a linear transponder, because as you changed one, the VHF, for example, the UHF would change in proportion, so you'd stay where you were within the transponder passband. So sophistication from anything from a handheld to two radios, to normal base station radios, to radios which are designed with satellite operations specifically. Lots of radios which aren't specifically designed for satellites, like the little Yaesu FT817 or 818, they will do cross-band or split operation, transmit on UHF and receive on VHF, or vice versa. And they're quite easy to use. Antennas. Okay. Once again, you can go degrees of sophistication go from the rubber ducky on the handheld to those antennas that I showed you earlier, where I used to operate on the phase 3 satellites, which were dual band or two crossed Yagis, one for VHF, one for UHF, with azimuth and elevation and switchable polarity, right or left hand circular polarization. They were great, and of course you did need those for those satellites because the signals were quite weak. That was probably one of the features of satellites like the phase 3 satellites, was that there was a limited amount of power for the transmitter, which had to be shared across the chunk of spectrum that was being used. So if somebody on the uplink was using very high power, their signal would correspondingly be quite high power on the downlink, and they could consume a lot of power in the transponder. So it was generally frowned upon to run any more than was absolutely necessary to make the contact, because if you were loud, everyone else went quiet. So if you were running at excessive power, you basically stole power from the transponder, from the rest of the spectrum. So they were quite weak signals. But anyway, I'm digressing. I'll show you a video in a second, and you'll get an idea of how things perform. I made a few contacts using the handheld with the rubber ducky. I listened to the satellite using the discone antenna outside here, and I used that antenna, which is the subject of the article in AR, to make some contacts, and you'll be able to see the difference between the three of them. With low Earth orbit satellites such as AO91 and AO92, you have at best about a 10 to 15 minute window, because it's going round, of course, a lot faster than the Earth is revolving. So you'll generally get a couple of passes a day, and some of them might be close to the horizon, some of them sort of midway, some of them almost overhead. But at best, you'll probably get about a 15-minute window at best. So, of course, you need to know when the satellite's coming over. And this, excuse me, this is all done with software. There are any number. Is that antenna still up there? Sorry. Yeah. Are you seeing me, or are you seeing that picture?
We're seeing you.
You're seeing me. Okay. I've lost my screen sharing again. I've lost my cursor. Here we go. Okay. All right.
That's better.
That's better. Okay, that's a screenshot of my phone the other day. I've got a little app on the phone which will track the satellites, and it's actually quite useful on the phone because the phone has not only a GPS, so it knows where I am, but it has a compass, so it knows which way to point it. So it actually tells you, you can stand there out in the field with your mobile phone, and it'll say, oh yes, it's going to rise over there, and it's going to set over there. So it makes things quite easy. I do have some links which I can send you for some for various software.
That would be appreciated. Thank you.
I'll just close that. I'll just bring. Sorry. I'm just going to start up. This is the old free version of Ham Radio Deluxe, which I'll just I'll just bring up some satellites. It's gone. Where's it gone? Here we go. Very good. Okay, I'll just I'm trying to move that over onto the other screen, but it's not cooperating. Are you seeing me, or are you seeing the shared screen at the moment?
Shared screen. Shared
screen. Okay. I think I might have to stop sharing just for a sec to move that across. Sorry. It's not going to work. All right, I might have to share the other screen, I think. Now I'm completely lost. Oh. I've lost me.
Afraid I can't help from here.
No, don't worry. I'll find it all in a moment.
Just a quick question. What is the oldest operational satellite, Oscar satellite, still up there working?
I think currently Oscar 7 is still working. A sec. I'm just going to close that. Are you seeing me, or are you seeing the?
We've still got you.
You're seeing me. Okay. I think the oldest one is currently Oscar 7, and a bit of an interesting story. Launched many years ago, exceeded its design lifetime, and then developed a fault with the battery. The battery actually went short, and the thing just stopped working. And then bizarrely, years later, the short in the battery seemed to clear itself, and when the sun shone on the solar panels, it sprung into life. And so it still goes, but it only works when the sun's shining on it. So there are periods when it's in eclipse and doesn't work at all, and there are periods when of days or weeks when the sun is shining on it, when it's not eclipsed, and it works perfectly. It still keeps going, even if it's got no batteries. It'll still run. So I think Oscar 7 is the oldest one still going. They never designed it that way. It's just bizarre that so the electronics was fine. The battery was the weak point. I was going to show you, and it's a little bit difficult to do it, but is the satellite tracking software. A lot of people now use mobile phones to tell them, because it'll predict as well. It doesn't just tell you in real time where the satellite is. You can ask for the predictions, and it'll tell you the passes over the next few days, what's coming up. The old version of Ham Radio Deluxe, it's got a satellite tracking feature in it, which was what I was trying to show you, but I can't share the screen readily. And one of the very popular programs for your laptop or your PC is called Orbitron, just Orbitron, and I've got a link, I think, somewhere to that. It used to be years ago what's called the Keplerian elements, which is how what you use to compute the position of the satellite. They used to read them on the WIA broadcast here in New South Wales, and it was like the stock market report. It was just sort of strings of numbers, which would sort of brain numbing stuff. It was these days it's all automatic. If you have a program on your mobile phone or on your computer, it goes and gets the Keplerian elements, keeps itself up to date, because they do change when it's in orbit. Things will change. There might be slight drag, or they might have to move it in orbit slightly, but it'll tell you when a pass is coming up, and so you can plan ahead. You know that or there will be a pass at a particular time, and it's going to be this far above the horizon. So yeah, I will. I'll send you those links afterwards. Techniques. There's a few things that we need to know about, which are a bit peculiar to operating satellites, rather as opposed to operating a terrestrial repeater. Apart from needing to know where the satellite is, the general way things are done with the satellites, even the FM satellites, is to leave the squelch open, because the signal will vary. It will go from absolute full quieting to completely disappeared. And if you've got the squelch on, it will chop in and out, and you'll particularly lose bits of it. So generally, people turn they open the squelch. The other complication is Doppler shift. You can imagine these satellites whizzing around the Earth. It takes, hour and a half or something to go all the way around. They're moving pretty quick. So you're standing still on the surface of the Earth, and as the satellite comes over the horizon, it is moving towards you at a fairly decent rate of knots. It eventually ends up overhead, and then starts going towards the opposite horizon, where it's going away from you at a fairly decent rate of knots. And I'm sure you're all familiar with Doppler shift. You've all heard the police car coming down the road, and as it goes past you, the tone of the siren changes, because the speed of the car is added to the speed of the sound, and essentially changes the frequency. Exactly the same thing happens with satellites. As the satellite is whizzing towards you, the frequency of the transmitter goes up. As it's going away from you, it goes down. So it is a bit of a function of frequency. The effect on 2 meters is not vast. It's usually in the order of a couple of kilohertz, 2 to 3 kilohertz, if that. So it might go from 2 to 3 kilohertz high to 2 to 3 kilohertz low from the beginning to the end of the pass. 70 centimeters more so. You can get up to 10 kilohertz. And I'm sure that you're aware that if you dial your FM radio 5 or 10 kilohertz off channel, you'll lose things altogether. So Doppler shift is a factor. On that little handheld radio I showed you before, operating on the AO 91 and 92 satellites, they are 70 centimeters up and 2 meters down. So generally what you'll do is leave the 2 meters, the downlink, on the nominal frequency. And I actually program in 5 different frequencies. They all have the same receive frequency, the same downlink frequency, but the 5 different channels I put in memory all have a slightly different frequency for the uplink, going from about 10 kilohertz low to 5 kilohertz, sorry, 10 kilohertz high at the beginning of the pass, to 5 kilohertz high, to the nominal frequency when it's overhead, to 5 kilohertz low as it's starting to go out, to 10 kilohertz low as it's just disappearing over the horizon. This is where the luxury of full duplex comes in. If you have a full duplex radio or 2 separate radios, so you can transmit and receive at the same time, you have the luxury of being able to hear your own signal, which is quite useful for the satellites that uplink on 70 centimeters and downlink on 2, because that way you can tell whether you're actually getting into the satellite. Other satellites, and probably the notable one, which is it's not really a satellite at the moment, is the repeater that they have on board the International Space Station, and it's the other way around. They have it basically is a repeater. It's the same sort of electronics that's on the satellite, but they turn it on from time to time on the space shuttle. It's the other way around. You transmit up to it on 2 meters, and the downlink is on 70 centimeters. So Doppler affects the downlink. But if you've got a radio which has been built for particular satellite operation, or you've got 2 separate radios, you can have that luxury of full duplex. You can talk and listen at the same time and hear your own signal. If you ever try it, use headphones, because otherwise it gets terribly confusing. With the old phase 3 satellites in those highly elliptical orbits, when it was a long way out, there's quite a time lag. You can imagine this thing's 25,000 kilometers away, and it takes quite a while for your signal, even at the speed of light, to go all the way out there and come back. And generally the only way you can operate those linear transponders is with full duplex. And it was incredibly confusing if you didn't use headphones, because you talk, and you would hear your voice coming back with a slight delay, and you keep pausing, and you could always tell when somebody didn't have headphones on, because they would talk like this. It was difficult. It's full duplex. It's not essential, but it is useful, and you can use 2 radios to accomplish that. I'll try and what's the other things that I should probably tell you about before I show you these videos. Satellites like AO 91 and 92 are not particularly stabilized in orbit. They will tumble somewhat, so that's why the signal is not always constant. You won't get a full quieting signal. The antenna on the satellite is sometimes horizontal, it's sometimes vertical, and you will get polarization changes. You'll get changes in the radiation pattern. It can be quite confusing. So let me try and find some videos. I'll just go to this. Oh. I'll just go. Let's get rid of that. Find my mouse cursor. Hang on, I have to bring my mouse back over here. Okay. Sorry, just bear with me for a second while I... It's very difficult because the Zoom controls are there. Okay. This first video, and I don't know how good the audio will be. It might blow you out of the room. It might not be audible. I'm not quite sure. This was a pass of Oscar 91 the other day on the Kenwood TS2000, just using the disco and antenna outside. Oh no, hang on, sorry. No, I started with the wrong thing, sorry. There we go. Okay. I'll just go a bit forward. Let's see if I can find some that's anyway, you get the idea. Can you hear me? Nod if you can hear me. Okay.
All good.
Was the audio at all? Could you make any sense of that audio?
Yeah, no problem.
Okay. Yeah, that was a pass on, and that was just listening on the disco and antenna, which of course is fixed. It's just vertically polarized. So there's a lot of very deep fades in that, and no possibility of altering things. So the next pass, I went out into the paddock with just the handheld, and I'll because the advantage of the handheld is I can wave the antenna around a bit and for the best signal. So this was just with a basic handheld. VK2AAK, VK2 Alpha Kilo. VK2 Alpha Kilo, CQ, VK2 Alpha Kilo. VK4GI, VK2 Alpha Kilo. Roger. Thank you for the 5x9. You're 5x9 here also. 5x9 here also. Name is Andy, Alpha November Delta Yankee, mid-north coast of New South Wales. Over, over. He might have been 5x9 on the absolute peak. I might have lied a bit. I'll just go forward and see if there's any. I think it's a little bit better quality further on. There was another station I talked to. Andy, Alpha November Delta Yankee, mid-north coast of New South Wales, 5 and 9 also. Thank you. Over, over. ZBJ, VK2 Alpha Kilo. Over. Thanks, Doug. Name is Andy, Alpha November Delta Yankee, yeah, so the audio is not particularly brilliant, but anyway, that's basically talking to. There were a couple of QSOs, one to Gladstone in Queensland, and the other to VK3ZDJ, and that's just on a handheld radio. You can literally do it with a $30 Baofeng, and I have, except that I sold the Baofeng and bought the HG1. But yeah, you can do it with a $30 Baofeng. Now, to give you an idea of how things are a little bit improved, this is with that Yagi that the article in AR was about. I've got that next to me here, and I'll show you in a minute. But this gives you some idea. There we go. VK2AAK, VK2 Alpha Kilo. VK3 X-ray Quebec, VK2 Alpha Kilo. VK3 XQ, this is VK2AAK. QSL Rob, thanks very much for the QSO. Name is Andy, Alpha November Delta Yankee, mid-north coast of New South Wales. Over. What was my report again? Sorry, you're 5 and 9. 5 and 9. Name is Andy. Over. Andy, thanks very much. Nice to catch you here. Okay, 3 X-ray Quebec with me. I'll just try and find a better bit. VK2AAK, you're 5 and 9. Name is Andy, Alpha November Delta Yankee, and I'm on the mid-north coast of New South Wales. What's the headway, please? His name is Andy, Alpha November Delta Yankee. Over. Roger, Andy, no problem. Good call signal. Name is where Bruce is located in Harvey Bay. Yeah, excellent copy of you, Bruce. Thanks very much for the QSO. Very good signal. So anyway, that gives you a. You can see me again.
Yeah, all good.
Okay, that sort of gives you a bit of an idea. You can use the the satellites with just a handheld and a rubber ducky, and it'll be a little bit variable, but it's doable. You will make QSOs. It's by far easier to use a small steerable antenna. With the easier satellites like AO91 and 92, you really don't want lots and lots of gain. If you have high gain, you have a very narrow pattern, and you'll find it quite hard to unless you're using computerized tracking or something. But a little antenna like that, which is oops, here's the antenna, which is like it's 5 elements on 70 centimeters, and it's 3 elements on 2 meters. There's a bloke on eBay that sells these, and he's been flogging them on VK classifieds. It's all made of stainless steel, and it's quite reasonably well built. It's these are actually tubes, not rods. They're hollow, and I imagine it's probably not the highest quality stainless steel, but it's actually not bad. And the beauty of this thing is that it does all pack up. You can just you can just unscrew the elements. They're all numbered. You probably can't see it. That one, it's just numbered, and the position on the boom is numbered here, and it all just goes together and comes apart. The beauty is with a handheld or a radio like that it's just a single feed point. It's so you don't have to worry about duplexes or anything like that. Supposedly it'll handle 50 watts. The feed is just a basic gamma match, so the pattern's not going to be sort of super perfect, but being as it's only 5 elements on 70 and 3 on UHF, it's going to be pretty broad anyway. But it does make a lot of difference being able to steer it. I had it on top of the tube that it came in, and I just had it set at a particular angle. That particular pass reached about 45 degrees, so I just set the antenna at about 20 degrees, so it was sort of halfway between the two, because the beam width of that antenna is broad enough that it's going to work. Company called Arrow, I think, make an antenna that is actually got like a handlebar grip on the back end of the boom, and you'll see people, particularly popular in places like China, you'll see them with a handheld in one hand and this crossed Yagi in the other hand, and they're pointing it up at the satellite. Works quite well. But yeah, anyway, we've been going for a while now, so I've probably bored you all to tears, but yeah, it can be quite a bit of fun. Not bad, really, when you can do that with a $30 handheld, talking to a 10 centimeter by 10 centimeter box whizzing around the sky. They're around 500 kilometers high when it's overhead, around 3,500 kilometers to the horizon, 3,500 kilometers to the other horizon. And it works quite well. What I'll have to do, I've got some links for some quite good information, particularly one from AMSAT in the UK, which is.
And if you want to send them to me, I'll send them out in the club newsletter.
Yeah, I'll do that. I'll email them too. It's probably easier.
Yep.
I'll do that shortly when I go back over to the house. So there's some quite good information there, which will actually sort of fill in all the holes, because I haven't really scratched the surface. But anyway, there we are. I'll pass it back to Stuart. Oh God, I've lost my mouse cursor again.
Oh, that's all right.
I don't think that's sharing anymore, is it? No.
No.
Yeah, we've got
It
you.
should be me. Okay.
Got a question
Back to
for you,
Stuart.
Andy.
Thanks for letting me bore you for an hour.
Oh, that's all right. Okay, what we're going to do is going to throw it open to Q&A now, just the forum, if you don't mind, Andy, and we'll.
No problem at all.
So, guys, don't talk over each other. And I think Michael, you were sort of hand up in the air, waving frantically. So we'll.
No, it's not frantic, but it's good.
Okay, go for it, Mike.
Andy, you were going to explain the difference between the disc cone and the other aerial that you had up before. The reason I'm asking is I do have a brand spanking new disc cone.
Mm.
So could you sort of give us?
Well, the reason I did that particular test was because the disc cone is the only vertically polarized wideband antenna I've got here. When I was up north in Kempseyshire, I had the 2 crossed Yagis on top of a tower. That was back in the 80s. Here, I have a 19 element Yagi for 70 and a 9 element Yagi for 2 meters, but they are not, they're rotatable, but I can't change them in elevation. So they're always pointing at the horizon. I can use them for satellites, for passes that are near the horizon, but I don't have any dedicated satellite antennas anymore. I use that little portable one for the little FM satellites. The disc cone, the only reason I used the disc cone was it happened to be the only antenna I've got that'll cover 2 and 70 at the same time, and I just used it because it was here.
No, it's all right. That answers my question. It covers the 2 bands. That's good.
Yeah, it does cover 2 bands. It's actually not bad. I put a I think that one's I think it's a diamond or one of the clone of the diamond anyway. And I put the antenna analyzer on it, and it's actually not bad. It's a bit dismal at 6 meters, even with that whip on it, although I think you probably can tune it a bit with the whip on the top. It's very good on 2 and 70. It's very good. It's a bit marginal at 1296, even though it's supposed to go to 1296. Probably not ideal, but 2 and 70, yeah, it works fine. Where it falls down with the satellites is that it is stuck in one polarization. You can't change it. And of course, it's even though a disc cone is wide band, it's not particularly high gain. It's probably no better than a quarter wave, if that. So it's probably not going to perform very much better than the rubber ducky on the handheld.
Thank you.
Just
Next one.
Just Richard, please.
Yeah, sorry guys, I just want to jump in. It was definitely not boring at all. Like Neil said, not 1 minute. I certainly enjoyed the stories about Oscar 10 because unfortunately I wasn't there when it happened, and this would have been a very, very interesting satellite from what I've heard. Unfortunately, AO40 never sort of got into action, because I think that would have been another extremely good satellite. I've worked satellites. I'm sort of in a similar situation like you. I have a rotator, but not for elevation, and I'm just having like a small 5 and 8 element 2 meter 70 centimeter Yagi up there. But I've certainly made contacts on the satellites there. I do have a 726. And I have to say that is the best sounding receiver out of the lot. And I have quite a few radios. The 726 is phenomenal when it comes to audio quality.
Yeah, it was an absolutely excellent radio. I bought mine. As I said, I worked for Dick Smith in the 80s. So I got it. I got a staff discount. And I poured I sold all sorts of stuff and bought that radio, and of course I bought all the options, the satellite module, so that it would do the full duplex, and it was absolutely brilliant on Oscar 10. I mean, it was really, that's what it was made for, was that sort of thing, was the linear transponders. These days we have quite sophisticated rotators, which can also be controlled by most of the software. So it's not just the radio. The software will control the radio. It'll take care of Doppler shift, and it'll move the antennas for you. You can just sit back and do it. With the old Phase 3 satellites like Oscar 10, when it was out, 25,000 kilometers away and just hanging in the sky, you didn't have to worry too much about tracking it. But
Yeah, it's a shame. It really is a shame that we haven't, that they don't plan. I don't know if they plan something like this, but one of these high orbit ones, that would certainly be very, very appreciated, especially with the lack of sunspots at the moment, you know, because you can still make overseas contacts and things like that. And yeah, sort of, I'm hanging in there, hoping that I know the Chinese are very active with satellites.
It would be very good to see some of those sort of satellites with a good linear transponder. They have launched. There is an amateur geostationary satellite up, or geosynchronous satellite up.
Unfortunately, not for us.
Not for us. It's
just out there.
Sky, and it's also not entirely trivial to use because I can't remember whether I think the uplink is 10 gigahertz.
Yeah. Now, I think now uplink is 2.4 and downlink is 10 gigahertz, and you can actually you can actually go
up and 10 down. That's right. Yeah.
There's actually a website where you can listen in like a SDR. Brilliant, absolute brilliant. Yeah. Unfortunately, we're just out. It's off the coast of VK6 basically.
Yeah.
Probably, I don't know, 2,000 k's off the coast, where you could have access to it.
That's right. Yes.
Yeah, hopefully we get something like this on our side, that we can sort of jump in as well, because I actually happen to have the 970 from ICOM with the 2.4 gigahertz module in it, so I could actually use that, you know.
Very good. I probably should have mentioned that the 2 meter and 70 centimeter transponders on satellites like AO 91 and 92 are not the only option. They do actually switch it to another mode, which has 1296.
Yeah.
And Doppler's a whole lot different there.
Well, I think Bill who's on the list here as well. He's actually very active satellite operator. I'm sort of in and out sometimes, you know. But I think he has used 23 on it, so I haven't done it.
I've used 23, and it's it's great. It was quite successful, and I didn't need an extremely high gain antenna. I just used a biquad. In actual fact, would you like me to show and tell? I've made this. Excuse me. I've made this pair of biquads. Hope you can see that.
Yeah.
One's horizontal, one's vertical.
Excellent. And
coaxial relay to switch polarity, and they're actually for the 1267, which is where the satellite frequencies are for that particular band. So I haven't done it for a while because lots of other things on, but yeah, you will hear me on the satellites from time to time. Usually the SSB ones. So
yeah. That reminds me of something I completely failed to mention, is that even the simple satellites, the simple FM satellites, you do need to transmit a CTCSS tone, which is 67 hertz in the case of those satellites. Mainly, there's a number of problems with, particularly these days, with people with DMR hotspots, and they tend to put them on anywhere that's convenient on UHF on 70 centimeters, and quite often they'll be on the uplink frequencies of some of the satellites. So CTCSS does help to overcome that. There are some other satellites, RO4 or 40, I can't remember, that actually require to be armed. They have a 10-minute timer, and you transmit 2 seconds of a CTCSS tone. I can't remember the tone, 100 and something hertz, one of the higher CTCSS tones. That arms the timer. You've got 10 minutes, then you can play with the satellite. But you can reset it. You can extend that timer by transmitting the tone at any time. Yeah. I failed to mention all of that. So
I think I'll just add one thing, and that is that there are it is possible from Southern Australia here to make overseas contacts on the SSB satellites and on the FM ones too. I've got Philippines and Thailand and Indonesia and New Zealand in the logbook, and I know Damien of 3EJ from our club, he has made quite a number of contacts into Indonesia and Papua New Guinea on the FM satellite. So it's a little bit of DX there, Richard. It's not every day, but it can be done.
Yeah. Sorry, guys.
Yes, I've got a couple of those biquads here. You remember the movie The World's Fastest Indian, and Burt Munro had a shelf in his shed, and it had sacrifices to the gods of speed, and it was all the melted pistons and things. I've got a shelf like that here, which is sacrifices to the gods of antennas, and it is there's quite a number of those biquads there. Some have been a bit more successful than others, but
yeah, we've had a good bit of success. Richard and I have been up on a couple of field days with the 1296 one, and had some quite good. If you get the elevation, of course, they're you know, that's what it's all about with that. Yeah. They're a good start off antenna.
Oh yeah, absolutely.
Good for round town and all of that. So
my 23 centimeter antenna up on the roof here is 37 elements. I wouldn't want to try using that with a satellite. It has the beam width of a razor blade.
and gain that it sucked the paint off the building next door.
Yeah, just about. I can fry sparrows at 1,000 feet. Yeah.
Andy, just one quick question in regard to polarization. How does circular polarization come to play in this space?
Circular polarization is actually quite it's quite good in that the satellites are tumbling, and so you will get polarization changes between horizontal and vertical. The loss between horizontal and vertical is greater than the loss between either and circular. So whilst you will lose some with circular, you won't lose as much as you potentially can if the satellite is horizontal and your antenna happens to be vertical, sort of thing. It'll be a lot more constant. You'll get a more constant signal with circular polarization.
You can eliminate a lot of the fading, and I had my antennas set up as circular, and they're not at the moment. I've got them switchable, and that's basically so that I can use them as general purpose horizontal or vertical antennas. So I have noticed that you get a lot more fading, but I've got just a switch on the bench that I flick between them. But it's one more thing to do. So I would recommend circular if you've got the
absolutely, yeah.
It's really easy to do. You don't need, all you need is just a set of cross Yagis and a couple of short bits of coax made to the exactly right length and connected correctly. It's not difficult. It's once you look at the schematic on how you do it, it's actually really simple.
Yeah, that's right. Yeah, the difficulty is more physical than technical in getting relays and things up at the antennas to do the switching.
Yeah.
But no, it does. If you can get circular polarization, it eliminates an awful lot of that fading. It is it's quite good.
Any comments from you, Bob? Bob's made a very nice little satellite antenna.
No, I've enjoyed the presentation immensely. The only thing that I've been doing is I've had the mute closed, and then I use the bar graph on the. I'm using a handheld FT70, and I use the bar graph to give me an indication as how good the signal is that I'm getting back. And I just I use a handheld 270, and just rotate the antenna so that I'm getting the best signal coming back, and that's the way that I get into it. And I've also had some fantastic contacts. I've New Zealand. I've got quite a few there, and as Bill mentioned, I got one up at Papua New Guinea, which surprised me. And VK6, I think I've had one. No, Far West VK5 I've had, but no, VK6 is on the sat. No, I've enjoyed your presentation. Thank you very much.
Well, thank you.
And also, I've enjoyed it too. For someone I've been playing around with them for a few years now, but it's always good to hear what other people are doing. And when you're talking on the radio, you don't quite, it's not quite the same as getting the detail that you've got. So yeah, well done. Thanks, Andy.
Oh, it's my pleasure. It's a bit of a sort of a foreign environment to do this on Zoom. I have to admit, this is the first time I've ever sort of given a talk on Zoom. I'm quite comfortable to stand up in front of a whiteboard and draw pictures and have a PowerPoint presentation and things like that. But it's all a little bit different, and I've probably sort of missed an awful lot of things that I would probably have liked to have talked about. But no, I hope it hasn't been too boring, and I've enjoyed doing it, but I've probably missed more than I've covered.
Well, as a suggestion, sorry if I butt in here rudely, maybe we can do it again, and you know, with more information, maybe we get some people active, and we actually have a chat with you on the satellite. You know,
yeah, absolutely.
So we all have a bit of sort of experience. Maybe even when we have our Christmas party after Christmas, our after Christmas party. We've done it at the club back then. Bill brought his equipment, and we did have some satellite contacts and stuff like this, you know. And especially, how can I put it? What fascinates me with this whole situation is that when you think about the size of a satellite, you know, especially the CubeSats, and they fly around like crazy in the sky, day in, day out, and you can actually use that. For me, this is just something, super interesting, and especially when you try to talk to people that are not in the amateur radio at all. If you bring up satellites, usually they open their ears, you know, when you say, oh, we have our own satellites up there. Oh, really? You know, so this is always a good talking point, because I mean, if you talk about normal two-way communication, people think like, oh yeah, whatever.
It's quite interesting. It does hold quite a fascination. We've got a fairly new member of our club who, not that long ago, he has a foundation class license, but he's technically very good. His background is in information technology, but he's always had something of a fascination with satellites. And but not long after he joined the club, we started playing with the slow scan television pictures transmitted by from the International Space Station.
Mm-hmm.
I don't know if you're familiar with that. They're actually going to do it's a week-long one in December, I think, from the 24th for a week. So that if you want to get slow scan television pictures from the space station, there's your opportunity. But he was quite fascinated by that and sort of picked this up very, very quickly. He's a smart cookie. Put it this way, he bought himself a DMR radio, and without sort of reference to anyone in the club, he got it all programmed, worked out how to do a code plug, did the whole thing, got it all working. So he's not a technical dummy. But the satellite thing has led to him. He's also got quite an interest in weather. So he's now got a setup with an SDR, a little preamp, an antenna that he's built himself, and he gets the weather pictures from the NOAA weather satellites. But the reason he uses an SDR is that he tried using his FT991. Of course, it's not wide enough. The filters are not wide. The NOAA satellites transmit on 137 point something megahertz, but the deviation is something like 35 kilohertz. It's not as wide as like broadcast wideband FM, but it's a lot wider than narrow band FM, and So he worked this out, and he's getting brilliant results. And boy, is he sort of keen. He's going to be a lifelong amateur, this bloke. He's absolutely hooked.
Yeah, you get that every now and then. I mean, sometimes someone comes in and they just really, you know, they got bitten by the bug, basically, you know. But
he's well and truly bitten. He rings me up. He doesn't live all that far away, and he says, "Have you ever tried Hellschreiber?" No.
Oh,
He said, "Oh, good. Well, would you like to try it? Because I've just found that mode on my software." So yeah, he tries it. He's into it all. Loves it. Good.
Yeah, Hellschreiber was one of my first digital contacts I had back in Germany.
Yeah,
was a guy, fantastic. You know,
oh, they're a lot of fun. Some of these modes, yeah,
yeah. Now, good stuff. As I said, I completely 100% enjoyed it, and as you said, there's probably a lot more to talk. But maybe do it again. You know, why not?
Yeah, we can do it again. I'll make some better notes. It's been a bit of a sort of slightly stressful day today because our water heater blew up, and so we've had sort of tradespeople fixing things today. So I was a bit distracted, but yeah, quite happy to you know, sort of do a follow up or.
Well, I don't think anybody here has been
more in depth one. You know, perhaps we can even organise to make some contacts over one of the satellites. So.
Well, Andy, if you would like to email me anything you would like distributed, and also if you wish limited to club members, quite happy to pass on an email address if you wish.
Absolutely, yeah. I'll include my email address, and yeah, members absolutely free to contact me if they want to, and always try to help where I can.
Andy, is there a somewhere I can go to for information on the International Space Station? It's
yes,
it's off at the moment, or has been off for a while.
Yeah.
When does it come on? That's what I want to do, because
the repeater, you mean, on the space station?
Yes, when it first came on, every man and his dog was on it, and I was going to give it. I gave it a rest. Yeah. And then by the time I decided I'd have a go, it was no longer working.
It's been a little bit sort of ad hoc. When it first got turned on, every man and his dog was on it, and of course, in typical fashion, people found that they couldn't get into it because everyone was trying to do it. So they were aiming high gain Yagis and a couple of 100 watts at the thing, because it just overwhelms it. Nobody could get in. So I was the same as you. It was so hard. I thought, I'll come back later when the novelty's worn off a little bit. But unfortunately, the schedule has been a little bit ad hoc, and even though there have been things published about, yes, they're going to turn it on, they haven't, and then suddenly find it has been turned on. So at this point in time, I haven't been able to find a reliable schedule as to when the crossband repeater is going to be on or off. I think that probably will settle down. They had a lot of problems with the thing over America. I mean, they were just overwhelming the thing. That's an interesting anecdote, actually. One of course, Russia has launched quite a number of quite successful amateur satellites, the RS series, and one of them in particular had it was sort of like a fuse that if you ran too much power at the satellite, it would turn the transponder off. So every time it flew over America, they tripped the damn fuse and turned the transponder off. And so it would fly over Russia and they turn it back on again. And it just went on day after day after day. The Americans would turn it off and the Russians would turn it back on again. So I think it was deliberate.
Andy, Mike again. You were talking about you normally do things on a whiteboard. Well, yep. With the background of your screen, that covered behind you, you could probably hang a whiteboard on that and do your drawings from there, because it's very, very clear. Your hookup is very clear.
Could, yeah. This I'm actually in. I live on 3 acres, and where I am at the moment is in my shed, and I have a corner of the shed which I've lined and is my shack. It's not that far behind me.
Yeah.
But and I've got another wall up in this direction, and I probably could. I do have a whiteboard, so I probably could do that.
That's if it makes you more comfortable doing it.
Well, I'm sort of used to a combination of PowerPoint, physical demonstrations, and drawing pictures.
Yeah. We all do that now and then.
Yeah.
Even when Richard and Bill were playing up at the club rooms, which we don't have anymore, we had a big whiteboard up there, and they were using the whiteboard as well.
Yeah.
And just one question in regard to we know we've got the repeater on the ISS. Has anybody tried sort of like doing it like an EME type activity using the structure of the ISS as a reflector?
I don't know whether they've actually done that. That's an interesting thing. Of course, aircraft enhancement is quite a well-known technique, and we often get that. I often, well, not so much these days because there's not so many aircraft flying, but it's quite a common mode. The VHF repeater in Sydney is about 240 something kilometers from where I am, and I can hear it reliably sort of day in, day out. But when you get an aircraft in the path, it nearly rattles the radio off the shelf. It's a huge boost. That's very interesting. I'd have to sit down and do the maths, I think, but as to the size of the target, because the size of the aircraft in aircraft enhancement does have quite a profound effect. So the space station, yeah, I don't know. That's a very interesting question. I might have to look into that. I mean, if you can reflect it off the moon, you would think that, maybe it'll work. Yeah,
well, considering it's a hell of a lot closer, and it's made out of metal, not made out of gravel.
That's right. Yes, that's right.
I've actually I heard of people attempting to do aircraft enhancement with light aircraft, which obviously not at the same altitude or the distance, and not really being a feasible thing. You need something like a 737 or bigger. So a commercial jetliner is really what you're aiming for. And I don't know how big the actual space station is, but I guess it's not that big. It'd be more like the size of a small to medium aircraft. So it would be worth a try, because I reckon if the challenge is there, someone will take you up on it, Stu.
Yeah, the ISS volume wise, as in all the modules, excluding the truss structure, occupies about the size of a large suburban house. So that's quite sizable.
Yeah.
It's the equivalent of a house of about 32 squares.
That's I've written that down. I'm going to look into that.
Yeah.
And if you try it
down there, tried meteor scatter at all?
I've heard about it, but not tried.
Okay. Interesting, because the Geminids meteor shower is on this weekend. I know this because it is cloudy and raining. So it's not going to, if there's any sort of astronomical event, you can absolutely guarantee that it's going to be cloudy and raining. But that won't stop meteor scatter. And my friend in the radio club, who's into all these modes and rings me up and asks me if I've done Hellschreiber, he was asking me about the various modes. He's running the WSJT software, and he said, "What do you know about these modes, and what do you know about that mode?" It wasn't that software; it was another one. But anyway, it's got MSK 144. He said, "What's that?" I said, "Oh, I think it's meteor scatter." He said, "Oh, I wonder how that works." And I said, "Well, to be honest, I'm not quite sure. The last time I played meteor scatter was donkeys years ago, and we did it with sort of very high speed CW, very high speed Morse." And anyway, I looked into it. It's all done by computer these days. It's really quite clever. It's a bit like FT8, where you have to, have your clock in your computer synchronized within a couple of seconds, and it works in 15-second windows. Yours transmits multiple messages for, over 15 seconds, and then the other station transmits multiple messages. Surprisingly good. Surprisingly good. It's surprising how well it works. There's very few mornings that I can't make a QSO over perhaps 1,000 kilometers on 6 meters with only probably 15 or 20 watts, I suppose, into the beam just off meteor trails. Computers have certainly changed things.
So how frequently does the conditions exist to allow that?
It's basically continuous. I mean, there's a meteor shower this weekend, so it'll be a bit enhanced, but pretty much every morning of the week, if I come out here at 7 or 8 o'clock in the morning, because for some reason they seem to sort of gather in the morning, and I can turn on this mode, turn on 6 meters, and it'll go across, and then there'll be a ping, and it'll come up with their call sign and their report, the signal to noise ratio, and all that sort of stuff. Amazing.
So what frequencies do they usually use for meteor scattering? Because I always thought this
predominantly 6 and 2.
Okay. Interesting.
It's 6. There's a lot of activity on 6. Yeah, MSK 144, quite an interesting mode.
Mm-hmm.
Okay.
Yeah, I've heard of meteor scatter, obviously, and watched YouTube videos and stuff, but I never really sort of got the hang of it, and plus with my older gear, it's a bit difficult to connect them up to the computer, sort of like, but yeah, interesting, very interesting.
Yeah, it is. It's as I say, I mean, it's decades since I tried it, and went back then. It was all done, sort of various ways of conjuring up high-speed Morse and decoding it, and yeah, these days it's all done from the keyboard. You put your call sign in and press go, and then
it does it for you. Yeah. It's all done for you, basically.
Well, yeah, a lot of it is. I mean, you do actually type back and forth, and that's in the messages, and it does require a degree of patience, because it might be a few minutes between pings that are long enough to support an exchange.
Mm-hmm.
But yeah, it's quite interesting. It's just you're speaking about reflecting off the International Space Station made me think about reflecting off meteor trails. So, and I'm sort of wondering if some of these modes might actually be applicable to things like trying to reflect signals off a small target like the space station. So, all worth thinking about, I think.
Definitely, it sort of seems to be possible. The possibility seems to be real. It's not something like not so far out that it's an imagination. So it'd be interesting.
That's right. Yeah. Well, yeah.
Sorry. I actually heard. Again, I watched on YouTube. They tried, I think, 10 and 15 meters via moon bounce.
Oh yeah,
they were successful. I think even 20 meters or so. So that was quite interesting. I mean,
EME is another thing which has been revolutionized by these weak signal modes. JT65 they use.
But you see, I'm not a big fan of that, to be honest, because
I have to agree. It doesn't. I mean, I've used FT8, but it doesn't really sort of excite me all that much.
Yeah.
JS8 or JS8 call is a little bit better, I think. It's a weak signal mode, but it's conversational. It's not a sort of canned exchange.
Yeah.
But you can actually have a QSO with that one.
You can actually have a QSO. It's it's more like playing radio than playing computers, but sort of an increasing number of stations are using these modes like JT65 with quite modest equipment, 100 watts and a reasonable Yagi, and bouncing signals, sort of having QSOs. Well, the computers are talking to each other. But this
for me, as I said, that's cheating, because if if I want to talk over the moon, it has to be Morse code or voice, and everything else for me is just. I mean, it might be.
Yeah, I can understand that. Yes.
You know, because if you can hear your own echo coming back from the moon, I mean, this is probably the pinnacle of radio, because I mean that's the DX queen, you know, if you want to. Yeah. So, and something on my to-do list. I'm not sure how and when, but I would at least would love to be part of it somehow, you know, to be there when it happens and
some
stuff.
Some of the weak signal modes are quite good tools. Things like Whisper are quite good at if you're studying propagation, and you know, perhaps some of these weak signal modes sort of, you know, lead you into doing things on CW or voice. At least they'll give you an idea of whether you're moving in the right direction. If you imagine, you know, if you can hear your own echoes on JT65 off the moon, well, then you know you're sort of, you know, you go to the next level and try it with a CW signal and see if you can hear your own echoes. And it does get a lot more sophisticated, because, or a lot more difficult. You do have to have you know, quite reasonable power.
There's a major jump in power and complexity. So if you can put out 100 watts and use JT65, at least you've said, okay, I can do that. Now I can move to the next step.
Exactly right. That's right. And it does. It's an order of magnitude in terms of power and antenna gain and receiver noise figure. I mean, these modes are very good at decoding signals which are below the noise. I mean, FT8 it decodes signals and you can't hear them. You don't know that they're there. You just trust that they are because the computer says it is, but you can't hear them. But,
yeah, well, that's why I guess if especially with moonbounds, you just go up in frequency. Then, you know, sort of like that you get the antenna gain out of something like, let's say, a 3-meter dish or so. You know, you probably I don't know. I'm just
it,
200.
There's always trade-offs. It's relatively easy these days to produce fairly substantial power at VHF at 2 meters and even to some extent at 70 centimeters. But the antennas and the structures are all quite big. But you see some of the guys doing very successful EME work on 10 gigahertz, and physically it's not that big. It's not that big a dish, but generating generating 50 or 100 watts at 10 gigahertz is not a trivial undertaking.
A lot of hard work.
But you probably, because of the size of the antenna, you probably could do this in the suburbs, sort of like, you know. So that's
right. Yeah.
Now I know there's a Russian station, RN6BN. I think he has 64 15-element 2-meter cross-Yagis combined together. Probably now more even, I don't know. And I mean, this just alone, the antenna array would be bigger than my property, you know, fully rotatable and stuff like this. But that's extreme, you know. And then let's say you get a 3-meter dish, you know, one of these XTV dishes or so, on 10 gig, that gives you a significant amount of gain.
Yeah.
You know? And I believe people use 3-meter dishes on 23 centimeters with about 200 watts, and they're quite successful, you know. So you wouldn't want to stand in front of it, but
what would you do with that many Yagis, Richard? Are you trying to toast satellites, or?
No, it's just that's what he does. I mean, like the big guns, some guys, HB9Q, I think they have a contest station in Switzerland. They have like a 15-meter dish or something, and 6-meter dish and 9-meter dish. They have like a massive array of they do contest. There's a contest station, and they literally they have S9 signal, QSO's voice over the moon. It's crazy. Absolutely crazy.
They got a very different credit card to what I have.
Yeah, well,
yeah. It takes the fun out of it. You want to go QRP or lower power and see what you can get away with.
Not in that case. There was actually a guy here in where was the fires a couple of years ago? King Lake, Douglas something. forgot the call sign now. The friend of Brian's Bravo Delta. He passed away. He had a 9-meter dish on a mountain where he lived, and he was running about 500 watts on 23 centimeters.
Whoa!
And he was literally talking.
Yeah.
Talking.
I've driven past it a number of times when it was up.
I've got an amplifier behind me. Oh, you probably can't see it. It's
we can, yeah.
It's that there, which is a work in progress. Which is it's a 2C39 amplifier, but it's probably only going to develop about 40 watts, if that. But underneath it, which you won't see, is a 70-watt amplifier for 2.4 gigs. So that will really upset the neighbour's Wi-Fi.
Oh, yeah.
Richard, that one you were talking about, Brian's mate, I've actually been in the shed when he's used it.
Oh, yeah.
So, and it was right on the razor back of the mountains, and how they ever turned their cars around and that, I don't know. But they managed it. But he had his own transformer down on the road. They had to put his special transformer in to give him power. So, yeah.
And what's
unfortunately, he's not with us anymore, so I'm not sure what happened with the antenna and stuff, you know. But
the antenna, I think, is still there. Somebody wanted to buy the farm, but no, they wanted to buy the antenna, and they also wanted to buy the farm, but she wouldn't sell the farm. So I think it's all still there, or most of it's still there, being dismembered, I think. I'm not sure. I'll have to talk to Brian about it.
VK2AAK, I think it was.
Something like that,
Mike.
Yeah.
And
I can't remember, but yeah, Brian, I went up there and he gave me a demonstration. It's good.
I tell you, with that amount of power and that amount of gain, you can get a part-time job working for CASA, getting rid of birds at the airport.
Well, the turning gears were the turning gears out of tanks. Brian helped build it. The worm and all that was the
yeah, from a turret of a tank.
Yeah.
Something like this there.
Yeah. It was quite an interesting day, that one.
All right, guys. I think it's 10 o'clock, and I think we've burnt enough of Andy's time already tonight. And thankfully, he agreed to come and talk to us. I think it's been an absolutely marvelous night. And like I said, Andy, if you've got stuff you would like distributed, we do a newsletter from time to time out to club members. So if you any links and that coming out of tonight that you want, or an email address to pass on to people who want to continue the conversation, please forward it to me, and I'll add it to the next correspondence going out.
I'm sorry if there's a bit of background noise. I run a Kiwi SDR here. I've had it turned off, and I've just turned it back on again. The reason it was turned off is it's in an enclosure, and one of the fans has started to fail, and it's howling like a banshee. And I've just
we can't get anything
on again.
We can't too bad. It's not audible. Not audible.
Good. Okay.
We can't hear it. Anyway, so any further questions before we roll up?
Well done, Andy.
Yeah, thanks for a brilliant presentation.
Not that I get into the satellites, but I'm interested in having a look at what people build things out of, especially Bill, that black backing on that antenna you showed us. At least it got put to good use, mate.
Yeah, as soon as I spied that, I thought, yeah, I can use a bit of that.
Yeah. Still got a bit left, fellas.
Where'd you scrounge that from, Mike?
Next door.
Off the balcony.
Okay, yeah.
It's the balcony on the accommodation.
The perforated metal, yeah.
That's right, yeah. And they made a few miscuts when they were putting them up, and threw it all in the bin. I got a lot.
Don't do that in front of Michael. That I got
attention. 2 rubbish bins, 2 large council bins full of offcuts, and that was something like about $200 in scrap.
Fair enough.
And I've still got a fair bit here, bits and pieces, but nobody wants to take up the offer. But anyway, Bill did. All right, Andy, well done. Thanks very much. Very interested. And the word will get out that you're now a Zoom expert.
Yeah.
Don't ruin his day.
Didn't skip a beat. He was fine.
It was fantastic.
Well, thanks, Andy. I'll definitely try to make a contact with you at some stage on the satellite. If I hear you, I will definitely jump in, of course. And it was an absolute pleasure. And I hope we do it again.
Yeah, excellent.
Yeah.
That's great.
Incidentally, Andy, I've got an 847.
What have you got? An 847?
Yeah, satellite radio. But I've never used it on satellite. It takes me all my time to work it on ordinary radio, let alone satellite radio. But one of these days.
One of these days, yes.
Yeah. All right.
All right.
Thanks very much.
Thank you, Andy.
My pleasure.
Thank you very much. Most enjoyable.
On behalf,
look forward to catching you all again.
On behalf of the club, Andy, I would like to pass on our thanks. And guys, round of applause, please.
Good. Thank you very much.
Thank you very much. And I will be in touch in the next couple of days, and that we'll just if there's any loose ends we need to tidy up, etc. And thank you very much.
No problem at all. I will email those links to you. Also, some information on what I've got on the schedule of the International Space Station crossband repeater.
Great, thank you.
Fantastic.
Yep.
All right,
Okay.
and
Good night.
thank you very much again, and I'm very, very grateful that you first off took my phone call, and secondly accepted the invitation.
My pleasure.
It's been a great night. Thank you very much.
Hey, Rocky, that antenna that he showed us, the stainless steel antenna, it looked very familiar.
Indeed.
Indeed.
I thought about that too, Rocky.
Indeed, I'm
There's a bit of a story there, Andy. I'll fill you on, update you offline on that one.
You can tell me about that one.
Yeah.
Okay.
All right.
All right.
Thank you, gentlemen. Thank you, Andy. I really appreciate it. It's been a fantastic night, and we'll bid you all good night.
Good night.
Okay, good night.